Hey guys, it's Mrs. Hageman. So this video is going to take you through part one of the Chapter 8 Similarity Desmos, focusing on Learning Target 8.1. I can use similarity criteria to solve problems. Slide 2 is a reference slide about what similar polygons look like, specifically triangles. Corresponding angles are going to be congruent. The corresponding side lengths are going to be proportional. And there's going to be a scale factor that is the same. Okay, remember, a scale factor tells you that a shape is dilated, either enlarged or reduced. We have a new symbol, a squiggle, kind of like a tilde in Spanish class. The symbol stands for is similar to. Okay, so we would say triangle ABC in this picture is similar to triangle DEF. The corresponding angles are congruent. As we said before, corresponding side lengths are proportional. And those side lengths are going to be enlarged or reduced by a scale factor called K. Slide 3 is a practice question about scale factor. So we have triangle RST is similar to triangle XYZ. We want to find the scale factor going from the triangle on the left, RST, to the triangle on the right, XYZ. So I'm going to draw an arrow. And we can clearly see that our triangle is getting smaller. So that means when we calculate a scale factor, which is a number, we want K to be less than 1. So how do we calculate? Well, first we want to match up our angles and our sides. So we know that angle R matches with angle X. We know that angle S matches with angle Y. And we know that angle T matches with angle Z. And so we can use the sides that are in between these congruent angle marks to tell us which sides go together. And when you find scale factor, it doesn't matter which one you choose to use. Okay, as long as they're matched up correctly. The other thing we need to know is we need to know what is the image and what is the pre-image. Pre means before. So we always want to know that the image is going to be after the pre-image. So the pre-image is going to be before the scale factor. So the image is going to be to the right after a reduction, and the pre-image is going to be the triangle on the left. So we're going to put a number from the triangle on the right, XYZ, on the top, and a number from triangle RST on the bottom. And we can pick any ones we want. So I'm going to pick 25 and 15. And those correspond to one another because they're in between angles R and T, which is purple and orange, and X and Z, which is purple and orange. So we have 15 over 25, and that's going to reduce to 0.6 as a decimal. Reducing it as a fraction, if we divide the top by 5 and the bottom by 5, we will get 3/5. And you will get 0.6 or 3/5 using any of the other sides, as long as you have the numbers from triangle XYZ in the top. So you can also get 3/5 by doing 12 over 20. Those both share a 4 in common. Or we can do 18 over 30. And those both share a 6 in common. Okay, so no matter how we set up our fraction, our scale factor is going to be 3/5 or 0.6. Slide 4. Now we're looking at angles. If you notice, when we match up the angles, we put congruent marks there. Angles are congruent when we have similar triangles. If angle R is 85 degrees, angle T is 40 degrees, and S is 55 degrees, then angle Z would be what? And we need to match that up based on the last question. So T goes with Z, and that was in orange. I think we had 3 loops on that one. And so what that means is no matter how long the sides are, these angles are going to be congruent. So if angle T is 40, then angle Z is 40. 55, you wouldn't be matching up correctly, and 24, you would be mistakenly applying the scale factor to angles, which we do not do. We're not going to do a scale factor with angles. There's no scale factor for angle measures. We always want to stay congruent. Slide 5, are the triangles similar? Compare the corresponding sides in order from smallest to largest. We don't know whether these are similar or not. So we're going to say yes or no. If yes, we'll get a scale factor. If it's not similar, that means one of our fractions is not going to match up with the other. So our smallest numbers in each triangle, we have an 8 here. We have a 6 here. So calculating 6 over 8, that's going to give us 0.75. And so we want to do this with all of the other sides. So the next number up would be 12 and 9. And we're going to put the number to the right first, similar to how we did the scale factor a few slides ago. So we're going to say that maybe we're shrinking and turning there. So 9 over 12, let's check what that is. That is also 0.75. And so if we get 0.75 for the next one, then it's going to be a yes. If we get anything other than that, it's going to be a no. So then we have 12 over 16, and that is 0.75. So this is a yes. And our scale factor is going to be 3/4, which equals 0.75. All of these fractions would reduce to 3 over 4. The easiest one would probably be 6 over 8 because you could divide both of those by 2. So yes, these triangles are similar. Slide 6, again, when we have these corresponding sides being proportional, what do we know about the angles? Corresponding angles are congruent. Not proportional, not similar. Angles are congruent. So we can mark those. A would be congruent to D. B would be congruent to whatever's in between the red and the green one, which is E. So B is congruent to E. And that means C is congruent to F, because that was in between the medium and the larger size number. And then our last one. This is probably the most work that we'll show out of all these slides in this first part of the video. So we have triangle DEF is similar to triangle JHG, and we want to find the value of X, which is over here. So X is side DE. So we're looking for how long DE measures. Now it's not going to be 15, 18, or 12 because we don't have congruent triangles. We have similar triangles. So we want to set up a proportion. We're going to cross multiply and divide to find X for our algebra. So we need to figure out what goes with X. So if we look and we color code our angles, we need an angle that has 2 loops, like angle D. And so the 2 loops over here is J. And you can also get that from your statement. D is the first letter, J is the first letter. And then we know that X ends at E. So we need to get the angle that matches to E, which is going to be H. And that's the second letter in our triangle statement. So X is going to correspond with 18. Again, it's not X equals 18, but that's going to be one of our ratios for our proportion. So X and 18 are going to go together. And then we need to match up another one, okay? So we're going to have X over 18 equals, and I can write it on the sketch pad as well. And then we're looking for another fraction set up the same way. We need a number from the triangle on the left, because that's where X was, to be our numerator. So you have 2 choices. You have 16 or 20, and you have to match those correctly. So we're going to do 20 and 15, just because those are next to those. And you could do 16 and 12. Make sure that we put the number with x in the numerator, because we had x in our numerator, so we need to go back to the triangle on the left. We're going to put 20 at the top and 15 at the bottom. So now we've set up a proportion. X over 18 equals 20 over 15. So to solve for x, we're looking for a number that would be in the same proportion, in the same ratio as 20 over 15. So we're going to cross multiply. And so we have 15 times x equals whatever 20 times 18 is. And so 15x equals 360. And you have your calculator here. Double check that. Yes, 360. And then we're going to divide by 15 on each side, because that's the number in front of x that we're trying to get rid of. And so x is going to equal clear this out. 360 divided by 15 is going to be 24. So x is going to equal 24. And check and make sure that that answer makes sense, okay? So 24 was matched with 18, and 18 happens to be the largest number in the triangle to the right, and 24 does in fact appear to be the largest number to the triangle on the left. So that means 24 over 18 is in proportion as 20 is to 15. I'm going to make that blue. So x is 24. And if you happen to do a scale factor for this one, this scale factor is also 3/4, because 15 and 20 share a 5 in common, and 18 and 24 share a 6 in common. So if we're going from the triangle on the left to the triangle on the right, we would have a similar scale factor to the one that we had a few slides ago, 3/4. And that does it for the first 7 slides, objective 8.1.